There we go. Let's talk about 3.5. We're talking about parallel and perpendicular lines, all right, and writing their equations. First off, I want to talk about everything we know about each of those parallel lines. Parallel lines, remember, they look like those red lines right there. They're never going to intersect, all right? They're never going to cross. They never cross. They never intersect, okay? Because of that, well, I want to think to myself, are they increasing at the same rate or a different rate? And here, if they're never going to intersect, they're increasing at the same rate, which means they have the same slope. Okay? You may remember that from a previous math class. All right? We also talked about perpendicular lines yesterday. Perpendicular lines, they're going to intersect, but they're going to form right angles. Okay? What do we know about their slopes? Well, if I have a slope of 4 over 5, then that m with the upside down t, remember the upside down t means perpendicular. My perpendicular slope would be negative 5 over 4. So if you look at these two, all right, the fraction is flipped, the signs are different. Okay, the signs are different, we call that the opposite. My fraction is flipped, we call that the reciprocal. So slopes are opposite reciprocals. Flip it, flip your fraction, and change the sign. Flip your fraction, change the sign. Here we go. First one, all right. All what I figured out is the slope. All right, these two lines are parallel because they're never going to intersect. Slope of the red line is 3 over 2. Well, what's the slope of the blue line then? Also 3 over 2. Okay, this little symbol, the 11 or the double L, means parallel. All right, so I always write that like M parallel. That means my parallel slope. That's what they're referring to. Okay, this next one, their slope is still the same, but obviously these lines are perpendicular. So since they're perpendicular, I'm going to do the opposite reciprocal, which means I flip my fraction. 3 over 2 becomes 2 over 3. That changes sign to make it negative. For part C and D, I want to write the equation now in y equals mx plus b form. Remember, b is your y-intercept. Okay, these two lines are parallel, these are perpendicular. Pause it, try to write the equations of those two lines. All right, so the 1/2, the slope should have been 1/2 because our slopes are the same if our lines are parallel. The negative 3 comes from right here because our graph crosses the y-axis at negative 3, which means our y-intercept is negative 3. Here our slope is 1/2, so our perpendicular slope, I flip it to make it 2 over 1, that changes sign to make it negative. Positive 1 is my y-intercept. I could also write it as negative 2 instead of negative 2 over 1. Remember, whenever you have a whole number, you can always write it as being over 1. Like 5 can be 5 over 1. 7 can be 7 over 1. 100 can be 100 over 1. All right, I want to talk briefly about this. Okay, first thing I want to say, all right, parallel slopes, we know their slopes are going to be, the slope of these lines are going to be equal or the same. Perpendicular slopes are a little bit special. All right, perpendicular slopes, if I multiply them together, I should get negative 1. So if you're ever doing any work and you want to figure out, if I'm doing it right, if I have the right slope for my perpendicular slope, I multiply my slopes together. So if I did this on the last problem, 1/2 times negative 2 over 1. 1 times negative 2 gives me negative 2 over 2, which is in fact negative 1, so that would check out. Okay. For this next slide, I want to find the slope of all 4 of these lines. All right, well, I'll start you on the first one, then I want you to try the next 3. The slope of line A, I'm going to go up 1 and over 3. So rise over 1, my slope is 1/3. And then I want you to try B, C, and D. Here are my slopes. I got 1/2 for B, up 1 over 2. 1/2 for C, up 1 over 2. Then negative 2 over 1, down to right 1 for line D. Remember, slopes, okay, slopes, if I look at a line, right, if I look at these 4 lines, I can see that 1 3 lines are positive slopes because they're increasing from left to right. Imagine yourself walking up the hill. If this line is a hill, I'm walking up the hill, which gives me a positive slope. This line, I'd be walking down the hill, so it gives me a negative slope. I'm going to skip this one and go to this problem. Okay? As we have the perpendicular line equation that goes through 2, 3, it's perpendicular to the line that they give. I'm going to write this down. I'd recognize that here, it's not in y equals form. It's not y equals mx plus b. Y is not by itself. So in order to find the slope, I have to subtract 2x to make it y equals negative 2x plus 2. Now I can identify the slope because it is in slope-intercept form. All right? So if you look here, our slope would be negative 2. Or negative 2 over 1. Okay? Leave that just as negative 2. My perpendicular slope, negative 2, is change the sign so it's positive and flip it so it's 1/2. Not positive 2. Again, this is negative 2 over 1. Mistake would be to write it as positive 2 instead of 1/2. All right, so here's our slope. Here's the point that it has to go through. Perpendicular. Since it has to go through this point 2, 3, 2 is my x, 3 is my y. I know that m is 1/2, and I'm trying to find b. So 3, 1/2 times 2 is 1 plus b, so b equals 2. So y equals mx plus b form, y equals 1/2 x plus 2. Now it just so happened that this had a y-intercept, this equation had a y-intercept of 2, and the original had a y-intercept of 2. That's not always going to be the case. Don't assume it'll be the case. All right, so be careful there. Don't assume that'll be the case. I actually want to go back to this problem. I forgot to do something here. Let's go back to this. The second part of this question asks you to determine which lines are parallel, okay, which ones are perpendicular. Well, parallel lines will have the same slope. So lines with the same slope are B and C. So I'm going to say B is parallel to C. Perpendicular lines will have opposite reciprocals. So B is perpendicular to D, and C is perpendicular to D because they have opposite reciprocal slopes. The rest of it, we're going to go, we'll do some with it in class, all right? But there's a big ideas assignment that goes with this. If you have questions, please let me know.